Okay, this is Unit 5, Day 10. So last day of the unit here. If you guys remember yesterday, Day 9, we talked about what a discriminant was. Okay, so the word discriminant helps us understand what the quadratic function's roots are going to look like. Okay, so it helps us determine it. So if you guys remember yesterday, b squared minus 4ac is the discriminant, and that will let us know 4 different cases. Okay, so one of the cases to memorize is if it's less than 0, and you think about anything that's less than 0 would be negative. And when does it make sense when you have a negative underneath the square root? When you have imaginary roots, okay? So that was like our case 1. And then we talked about, well, what happens if it's exactly equal to 0? There's one real solution. That's when it was tangent. Okay, so the parabola only intersected the x-axis one time. That was case 2. And then case 3 and 4 were both greater than 0. And greater than 0 means that it is positive. And our 2 different cases was if it's greater than 0, it's positive. If it's a perfect square, there were 2 real rational roots. And if it was not a perfect square, there was 2 real irrational roots. So those were our 4 cases there, okay? So example 53, for what values of a will the parabola y equals ax squared plus 4x plus 2 not cross the x-axis? Now this whole little hint here is not going to be here when you take a test. So the key words to pay attention to, it does not cross the x-axis. You need to think it's imaginary. And if it's imaginary, it's going to have a negative discriminant. And if it has a negative discriminant, then it has to be less than 0. Okay, so now let's look at that. So A is A, that's what you're solving for. B is a positive 4, and C is 2. So my discriminant is 4 squared minus 4 times the A times my C. And it is going to be less than 0 because of the does not cross the x-axis. So when I simplify this, I'm going to get 16 minus 8a is less than 0. Okay? So now, I'm going to either add the 8a to the other side, or I'm not afraid of negative. So if I minus 16, I'm going to get negative 8a is less than negative 16. Now I'm going to divide both sides by a negative 8. And because I'm dividing by a negative, you need to remember to flip your sign. Okay? So the less than actually becomes greater than. So I'm going to get A is greater than positive 2. So what does this mean? That means if your leading coefficient A is strictly greater than 2, so it means it can't be 2, then that would force this quadratic to have imaginary roots, okay? If it was 2 or lower, then you're going to get one of the other 3 cases. It might have 1 root, it might have a positive root that is rational or irrational, but to make it be imaginary and not cross over the x-axis, it has to be a number greater than 2. Okay? Example 54. For what value of k will the quadratic equation have real and equal roots? So your key word to memorize is equal. If they're equal roots, it means it has 1, and you set it equal to 0. So my A is 1, my B is negative 4, and my C is represented as k. So B squared, because B is negative, put it in parentheses, minus 4 times 1 times my k, and I'm going to set it equal to 0 because of that word equal. The only one that's going to have equal is if it's tangent. Any other time it would be greater than or less than. Okay, so I'm going to get 16 minus 4k equals 0. Minus 16 from both sides. And when I minus 16, I'm going to get negative 4k is equal to negative 16. Divide both sides by negative 4. And I get that k has to be equal to a positive 4. If k is equal to a positive 4, then that would cause us to have real and equal roots. Example D5. Find the largest integral value of k that will make the quadratic equation have 2 real roots. So the key word is 2 real. If it's 2 real, then it's a positive number, which means you're going to set it greater than 0. Who cares if it's a perfect square or not a perfect square? In order for them to be real, it's going to be greater than 0. So my A is 2, my B is 7, and again, my C is represented as k. So I'm going to have b squared minus 4 times my a times my c is greater than 0. So 49 minus 8k greater than 0, minus 49 from both sides. Yes, you could add the 8k to both sides, but you end up with the same answer. So you're going to get negative 8k is greater than, greater than negative 49. Divide both sides by a negative, but again, here we go again. So you have to remember to flip your sign because we're dividing by a negative, and you're going to get that k has to be less than 49/8. Now 49/8 is a little hard to look at, so that's approximately 6.125. So if you go back and read the question says, find the largest integral value of k that makes it. So now guys, the highest it can go is 6.125. You can't say 7 because this is the max it reaches. So the largest value it can have would be 6. Okay? The largest value, integral value, would be 6. Alright, sum and product of the roots. These are really, really important. It is important that you memorize these, but you need to know by heart that the sum of the roots is equal to negative b over a, and the product is c over a. Okay, a little easier way to look at the sum is opposite of b over a. Okay, so whatever b is, change its sign divided by a. This next example here just kind of tells you how you're going to derive it. So if you're looking at the quadratic formula here, one of your roots would be negative b plus the square root of b squared minus 4ac over 2a. And your other one would be negative b minus the square root of b squared minus 4ac over 2a. So when you see the word sum, that's why you see that we're adding it right here. And then what that simplifies to is that negative b over a. So what we are just showing you here is how you derive and why the sum is negative b over a. Same thing happens here with the product. So in the middle here, you could see we're multiplying it. And once you simplify everything, that's why the product is equal to c over a. Okay? So example 57, consider the quadratic equation, okay? I see that my a is 2, my b is 5, and my c is 8. So it says find the sum. So I know that the sum is equal to the opposite of b over a. So my sum is equal to negative 5 over 2. What does that mean? If I were to use the quadratic formula and I were to find the roots of this, if I added those roots together, the sum would be negative 5 over 2. Okay? Your product is equal to c over a. So my product is 8 divided by 2, and I simplify that to 4. So there's my product. So again, if I use the quadratic formula and I found the roots of this equation, quadratic, then if I multiplied them together, it would result in a 4. Example 58. Consider a quadratic equation whose roots are 5 plus or minus 2i, meaning one root is 5 plus 2i and the other root is 5 minus. Find the sum. Sum means to add them. So I'm going to take 5 plus 2i and I'm going to add it to 5 minus 2i. So you're going to combine like terms. So 5 plus 5 is 10, and then the positive 2i and the negative 2i cancel. So the sum is equal to 10. Okay? Product. I have to multiply them. 5 plus 2i, and I'm multiplying it by 5 minus 2i. Now, these are imaginary conjugates, so we have a shortcut. You could just do a squared plus b squared anytime it's imaginary conjugates. If you forget that little shortcut, then FOIL this and you'll get the same result. Okay, so remember, these are my A's, these are my B's. So when I say A right here in the shortcut and I have to square it, I'm taking 5 and I square it and I get 25. Why is it always plus? Well, because one's plus and one's minus, and then the I times I is a -1, so it always reverses the sign and makes it positive. Your B, it doesn't matter if you think of it as 2 or -2. When you square that B, you're going to get a 4, and that results my product is a 29. Part C, okay? Using your work from part A and B, it says write the equation for the quadratic in the form of ax squared plus bx plus c equals 0. All right, so basically up top, we knew that our sum was equal to 10. Okay, well, watch how easy this is. If I put 10 over my imaginary 1, remember, sum is the opposite of b over the a. So what they're saying is negative b equals 10. That means the real b is equal to negative 10. Okay? If negative b is 10, then the real b is equal to negative 10. Or another way to think about it algebraically, divide both sides by this negative to get rid of it, and then you result in that. Your a is clearly 1, because that over, any whole number can be put over 1. Your product is equal to 29. Again, put that imaginary 1. And product is equal to c over a. So that's telling us our c is 29, but look guys, our a is still 1. So I know a is 1, b is -10, and c is 29. Now when I substitute that into the standard form of this quadratic, I'm going to get x squared minus 10x plus 29 is equal to 0. Okay? Last example here, 59. Same thing, but look, these are irrational. Those are two real irrational roots. Okay, they are conjugates still though. So now I'm going to sum them again, just like I did before. And then down here, I'm going to multiply them to find their product. Okay, so the sum would be 3 plus radical 2 plus 3 minus radical 2. When I combine like terms, 3 plus 3 is 6. But then my positive radical 2 and my negative radical 2 cancel. So my sum is 6. Okay? So I'm going to set that up down here and write sum equals 6. All right. My product, 3 plus radical 2 times 3 minus radical 2. The shortcut when they are irrational conjugates is first minus last. So my first terms are 3. I multiply them. Remember, F and L is only from FOIL. So when I multiply my first terms only, I get 9. And it's always minus. Why? Because one's positive and one's negative. And radical 2 times radical 2 is just a 2. And I get 7. So now I know my product is equal to 7. All right, part C is exactly like the other part C that we just did in the previous example. So remember, put these over your imaginary ones. And this is signifying that this is the opposite of B, and that is A. This is C, and that is A. So if the opposite of B is 6, then B has to be -6. And this is telling us that A is 1 and C is 7. Okay, so write the equation for the quadratic. It's going to be x squared minus 6x plus 7 equals 0. Okay, now part D says write an equation for the quadratic that you just found in part C. Now remember, x squared minus 6x plus 7 equals 0 is what we just found in part B, but it says with a leading coefficient of 2. So it wants me to switch this to 2. Well, if I switch that to 2, I have to switch everything else to 2. So it's going to result in 2x squared minus 12x plus 14 equals 0. Okay, so it's that easy. You're just distributing and multiplying the 2 through the whole equation.